Let's look at example 5. Now, this one is definitely getting into the realm of more complicated. Now, the first thing I notice is I've got fractions here. Now, I don't know about you, but I don't particularly like fractions. So first thing I'm going to do is multiply this whole equation by x in order to make our fractions go away. So top equation I didn't mess with, left that alone. Bottom equation I times everything by x, and I get that. And that looks a lot better than what I started with, at least. Now, at this point, I typically have a lot of students want to do elimination because of this. Let me show you. If I take the bottom equation and I rearrange it, flip the x and the y places, students will typically notice that, hey, I can subtract these two equations, and then these will go away, eliminate. Which is all well and good, except here, so I have x squared minus y squared. X minus x goes away, and negative y minus a negative y also goes away. So I get this. But remember, the whole goal is to be able to eliminate to an equation with a single variable. You can't solve it if there's more than one variable still there. So elimination in this case is not going to work because it doesn't eliminate to a single variable. So instead of trying elimination, let's go back to the drawing board and maybe we can try some substitution. So what I'm going to do is take my second equation and solve it for x. So minus y squared plus y and now I have an equation for x, which I can then go into my other equation and substitute that equation in. So negative y squared plus y. This is squared, so I need to FOIL that out. This is just adding, so I don't need the parentheses there. So let's FOIL this together really quick. Negative y squared times negative y squared is positive y to the fourth, minus y cubed plus y squared. And you have probably already noticed that things are going to cancel. So I have y to the fourth minus 2y cubed equals 0. They have a y cubed in common, which I can take out. And because both of those things equal 0, I can set them individually equal to 0 to get y equals 0 and y equals 2. And there's my y values. Now, at this point, since I have some values of y, I could plug those back into either equation and solve for x. I'm going to notice really quickly that if I plug these in for y here, then it's a lot easier to solve for x, versus if I plug it for y here, I'm going to end up factoring to solve for x. So I'm going to pick my second equation. Let me rephrase this. So I have y equals 0 and y equals 2. Plug both of those in to my second equation. So I got 0 squared minus 0 plus x equals 0. 2 squared minus 2 plus x equals 0. So 0 minus 0 is just 0. I get x equals 0. This is 2 squared, which is 4 minus 2 is 2. So I get x equals negative 2. So those are my x values. So now I have a whole point here. First point is 0, 0. Second point is -2, +2. And these are my 2 points. Now, remember the step that we've typically been skipping for all of these problems is you know that these work for this equation, but you don't actually know that these points work for either of our original equations. So at this point, you would need to plug 0, 0 into here and here to make sure it works. And you would need to plug -2, 2 into here and here to make sure it works. Now, you may have already noticed one of those doesn't work very quickly. This one. If I plug 0, 0 into this one, I'm going to end up dividing by 0, which doesn't work, which means that is a fake solution. This is the only real intersection point. So, there's your first example of a much more complicated nonlinear system of equations. In the last video, we'll do our last example, example 6, which is definitely the hardest example of the whole day.